Find the sum of all 3-digit natural numbers which are divisible by 9. To solve this math problem, we have to do 3 steps. One is we have to write all 3-digit natural numbers, and then among those 3-digit natural numbers, we have to identify the natural numbers which are divisible by 9. Then the third step is we have to add them all. Okay, so already we know that natural numbers are integers which start from 1. That is 1, 2, 3, 4. So these are all called natural numbers. Okay, among the natural numbers, first we have to write the 3-digit natural numbers. So the very first 3-digit natural number is 100. Because before 100 we have 99, it contains only 2 digits. The very first 3-digit natural number is 100. The next one is 101. The next one is 102. The next one is 103. So it will keep going. The last 3-digit natural number is 999 because the next one is 1000. It contains 4 digits. So now I have written the 3-digit natural numbers over here. Among these numbers, now I have to identify the natural numbers which are divisible by 9. Okay, so here, so to identify the 3-digit natural numbers which are divisible by 9, so what I'm going to do is I'm going to divide the first natural number 100 by 9. Okay, so when I divide 100 by 9, I have to check how many times 9 goes into the first digit 1, 0 times. So let's check the number formed by the first 2 digits, which is 10. How many times 9 goes into 10? 1 times. 1 times 9 is 9. If I subtract the 9 from this 10, I'll be getting 1. Okay, 9 goes into 1 0 times, so we can bring this 0 down, then it will become 10. How many times 9 goes into 10? Again, 1 times. 1 times 9 is 9. Okay, when I subtract this 9 from 10, I'm getting the 1. So 1 is a remainder. So when I divide 100 by 9, I'm not getting 0, I'm getting 1. When I divide 100 by 9, if I get 0 as a remainder, then I can say the first 3-digit natural number 100 is divisible by 9. But it is not divisible by 9 because we don't get remainder 0. Only if I get remainder 0, we have to conclude that the number 100 is divisible by 9. Okay, now what should I do? So I have to check with the second number. In case if the second number is not divisible by 9, should I check with the third number? In this way, so I have to keep checking. So it will be time consuming, but there is a trick to find the first 3-digit natural number which is divisible by 9. For that, we can apply the trick over here in this long division. So for that, what I need to do is have to subtract this remainder 1 from the divisor 9. If I subtract the remainder 1 from the divisor 9, I'll be getting 8. Sorry. Okay, now what I need to do is I have to add this 8 to this dividend 100. So 108 is the first 3-digit natural number which is divisible by 9. So you don't have to check one by one. If 100 doesn't work, you have to check 101, 101, 102. It's not like it's time consuming. Instead of that, here in this long division, that is when I divide the first 3-digit number by 9, in this long division, so I can use the trick what I've explained so far to get the first 3-digit natural number which is divisible by 9. So this trick will not only work for this particular case that is divisible by 9, even if it is divisible by 3 or 4, divisible by any number, this trick will work. Not only for 3-digit number, even for 4-digit number, 5-digit number. So any case similar to this one, the trick what I've explained so far will work. Okay. So the first 3-digit natural number which is divisible by 9 is 108. Okay, so what is the next 3-digit natural number after 108? What is the next 3-digit natural number which is divisible by 9? So again, do I have to check 109? No, it's very simple. You just add 9 to this one. So when I add 9 to this one, it will be 117. So after 108, 117 is the next 3-digit number, 3-digit natural number which is evenly divisible by 9. What is the next one? Add 9 to this. 126. Sorry. Okay, so in this way we can keep adding to each 3-digit natural number to generate the next 3-digit natural number which is evenly divisible by 9. So if I want to get the fourth 3-digit natural number which is evenly divisible by 9, have to add 9 to this. When I add 9 to this, it will be 135. Okay, in this way it keeps going. So what is the last natural number, last 3-digit natural number which is evenly divisible by 9. So it's very simple. Just take the last 3-digit natural number and divide this 999 by 9. So it's a multiple of 9. So 999 is divisible by 9. So the last 3-digit natural number which is divisible by 9 is 999. So among all the 3-digit natural numbers, I have identified the 3-digit natural numbers which are evenly divisible by 9. Okay, so when I look at this one, actually the 3-digit natural numbers which are evenly divisible by 9 form a sequence. So what type of sequence is this? So the difference between the first two consecutive terms is what? 9. What is the difference between the next two consecutive terms? 9. Next, 9. So the difference between any two consecutive terms in this sequence is 9. So clearly it is an arithmetic progression. So now our aim is to add all these values. That is, I have to add 108, 117, 126, 135. So the target of the question is we have to add all 3-digit natural numbers divisible by 9. So I have added all the 3-digit natural numbers which are divisible by 9. So how can I add them? There is a formula because I've already told you it's an arithmetic sequence. So to find the sum of all the terms in an arithmetic sequence, there is a formula. So the formula to find the sum of the digits in an arithmetic sequence is Sn is equal to n over 2 times A1 positive An. Okay, here n stands for the total number of terms in this arithmetic series, and A1 stands for the first term of the series, which is 108, and An stands for the last term. In this case, the last term is 999. So still we need the value of n. N means the total number of terms from 108. If there's a first term, second term, third term. In this way, if I keep counting, how many terms do we have in this arithmetic series? So there is a formula to find the number of terms in an arithmetic sequence. It is n is equal to the last term negative the first term divided by the common difference d positive 1. This is a formula to find the number of terms in an arithmetic sequence. Okay, here let's find the value of n. So n is equal to the last term is 999 and the first term is 108 and the common difference is 9 positive 1. Okay, so let's subtract 108 from 999. It's 198 over 9 positive 1. Okay, here we can simplify this one. 9 goes into 9 one times, 9 goes into 89 9 times. 9 times 9 is 81 and we have 8 left in the 89. That 8 can be taken along with the next digit, then it will become 81. Again, 9 goes into 81 9 times. That is, when I divide 891 by 9, it's 99. 99 positive 1 will be 100. So there are 100 terms in this arithmetic sequence. Okay, now what I need to do is here in this formula, I have to plug in n is equal to 100 and A1, the first term is 108 and An, the last term is 999. Okay, now let's plug in all these values and evaluate the sum of this arithmetic series. So that gives you the sum of all 3-digit natural numbers which are divisible by 9. Okay, let's continue this one on the next page. This is a formula we have to find the sum of the terms in an arithmetic series. Okay, now what we need to do is we have to plug in n is equal to 100, A1, that is first term, is equal to 108, the last term, that is An equals to 999 into this formula. Okay, let's plug in these values. Then I'll be getting S100 equals to 100 over 2 times A1 is 108 and An is 999. Okay, 2 goes into 2 one times, 2 goes into 100 50 times. So I get 50 times. When I add 108 and 999, it will be 1107. Okay, when I multiply this 50 and 1107, I'll be getting 55,350. So the sum of the terms in the arithmetic series is 55,350. So that is the sum of all 3-digit natural numbers which are divisible by 9 is 55,350.